Okay, I think I'm live. I can't see my screen in the preview though, which is worrying me a little bit. Okay, there we go. Yes, hello, welcome. It's live streaming. Today, we are going to be doing some named entity recognition using Spacy. So this is something that I've seen a lot of requests for on the forums recently. People who are sort of interested in named entity recognition, and not everybody knows that the thing that they're asking for is that, right? So named entity recognition is a natural language processing technique where you take text as input and you identify the parts of the text strings that refer to specific entities. So an entity would be like the country of Poland. And you want to be able to take in text, and then every time you see the word Poland, highlight it and be like, okay, yes, this is Poland. And then every time you say Poland, you want to know that you're referring to the same entity. And to do this, we are going to be using the Spacy natural language processing library. So if you guys aren't familiar with Spacy, it's an open source library. If you are coming from more of an academic background, you might be more familiar with NLTK, the Natural Language Toolkit, which has a lot more features, but is also more focused on research applications. So if you're, building something new, then for a research project, then you're probably going to use NLTK. But if you're interested in putting something into production right now, I wouldn't recommend NLTK. It's a little bit slow. It's a little bit fiddly. Whereas Spacy is a open source project that is very fast. So I am going to get started. And while this kernel launches, I'm just really going to quickly... There we go, creating notebook. I'm really going to quickly tweet that I am online. Sorry, I wasn't looking at the mic, which is why I sounded weird there for a second. I hope you guys all had a good week. It's Friday for me. I'm sure it's Saturday for some of you guys. And it's been really busy for me. I'm working on a talk for a conference I'm going to, and it's been a lot of work. I'm on Twitter now. I should have done this right before I started, but the software I use, Streamlabs OBS, I used to use OBS, but it doesn't connect to YouTube easily, decided to update on start, which is never something I want from software that does something time sensitive, ever, like a chat software. So I was trying to figure out how I was going to do my stream if my encoder didn't launch. Happening now. Okay, let's get down to business. Let's start with a good title. Named entity recognition. And I am gonna want pandas. I'm gonna want, Spacy. And I'm gonna want to read in our data. So the data set that we're using is a data set that takes information on 3 different websites. So Emergent, PolitiFact, and Snopes, and these are sort of like fact-checking websites. And I think I'm probably going to use Snopes, maybe? If you haven't seen it, we do have this really nice little data set preview thing that we've just added. So in this table, we have labels about whether or not the rumor was true or false, and as you can see, most of them are false. We also have claims, so this is what the rumor was, and I think this is what we're going to be doing named entity recognition on. And then we have the topic, so this is sort of like the general category that this would fall into, and then the page. So this is scraped from Snopes. And this is the file path to this file. So when I read it in, I'm going to use this. Actually, copy path to clipboard. That's so nice. We just launched the new data editor, and I'm still finding all the like little secret quality of life updates the engineering team made. And I'm a big fan. I'm really liking it. All right, PD read CSV. Oh, I can close this now. Boop. There we go. And the file that we wanted, is this big enough for you all? Are you seeing this okay? Let me know if I need to zoom in more, because I know sometimes I'll be too zoomed out. And let's quickly look at our file just to make sure it read in okay. Okay, and it looks like we have some additional columns, so date, URL, and then some other things. But the thing I'm really interested in is this claim. Excuse me. And the claims look like they're repeated, so I want only the unique ones. Check out the data. Yes, of course I can zoom in. Whoop, whoop. Is that better? Oh, you know what? I can also get rid of that so we got more space to work with. Okay, so these look like they're repeated. So you can see this, Georgia recently became the first US state, blah, 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 and it's repeated several times. So I'm gonna get just the unique ones and also spell the correctly. And if I remember the pandas command for that, I think it should be, what's this called? Claim data.claim.unique. I think that should get me all the unique ones. We'll call this claims, I think. Just quickly look at the first one just to see what that looks like. I did it. Excellent. And the second one is incorrect. Okay. An image depicts a fatal collision. Oh no. Okay. But if we were looking at named entity recognition, Chevy Suburban is an entity, tractor trailer is an entity, infant is an entity, and then image could or could not be an entity depending on what you're thinking about, and collision could or could not be an entity. So these usually use dictionary-based techniques. We have a dictionary of all of the entities that you're interested in, and you go through and you match them. Okay, so now we have a list of claims, and I'm getting a spam call. So we're going to look at the Spacey docs. Spacey named entity recognition. Yes, but there we go. I actually want the named entity recognition. This, interesting. I thought the docs for Spacey were blue. Entity recognition. Oh, okay. API. Maybe the tutorials are blue. Yeah, there we go. This is what I'm expecting. Training models. Pipelines, processing pipelines. Linguistic features. Here we go. Named entities. Here we go. So a named entity is a real-world object that's assigned a name, a country, person, product, or book title. If I can just get back to where I was. Spacey can recognize various types of named entities in a document by asking the model for a prediction. And again, like a lot of NLP techniques, it's sort of fuzzy, so it's not necessarily always going to be exactly right. So named entities are available as the ends properties of a doc. So the way Spacey generally works is you take your text and you use this NLP function to create a doc, and then the doc has various qualities about it. And the one that we are interested in is the entities inside the doc. So the first thing I'm actually going to do is I'm going to copy and paste the sample code. So this is something I'll do a lot when I'm getting started with something, just to make sure I have everything installed correctly and that the version that I'm using is the same as the version that the documentation is showing, because that's not always the case. So you can see with this example, and this is the the data set that we're using to find the entity. So this is for like the dictionary we're looking stuff up in. And it's English, so it's only going to work for the English language. So if I did this for French or Chinese or something, it wouldn't work. Core, I don't know, the important ones. Web, so it's probably trained on web data. Probably web and social media data is probably what the SM is. I don't know. I'm not too familiar with the guts of Spacey. I've just used it a couple times and been impressed. So, all right. So first off, let's try it with our data and see if we have any trouble. And I'm actually just going to start with the first claims data. Oh, actually, let's do the one that we looked at with the tractor trailer. So what it's got as entities was Chevy and Suburban and not tractor trailer, which is fine. And it recognizes that Chevy is an org, that Suburban is a product. Examples is a person. I don't remember that from... Where's that? See examples. Oh, okay, so there was this sort of thing here. I don't know that I'd call examples a person. That doesn't seem quite right to me. Let's try this first one. Georgia recently became the first U.S. state to ban Muslim culture. That seems false to me. That seems like a fake thing that somebody made up. Okay, so here we have Georgia. GPE is probably geopolitical entity, so like a country. First, an ordinal, another country, Norp, something, Muslim. Yeah, those, I'd agree. That's what I'd say as well. I'm not, first is a little bit odd, but again, it depends on the dictionary you're using. So you could also train or upload or manipulate the dictionary so that you had better coverage for the specific topic that you were working on. Okay, so that works pretty well. So let's, what happens if I just do it for the whole thing? And I'm actually right now, I'm gonna get rid of these. Oh, and this is the index of the starting and the ending character. So if I wanted to extract it, or do something with it, I could using that. Let's see if this works. Okay, it does not work. Argument string has incorrect type, extracted string got numpy array. So it's an array and it won't take arrays, it'll only take strings. So, and that's just as well because I don't want all the entities in one big document. I'm interested in my sort of pie in the sky vision for today, and I don't know if it's going to happen or not, is that I want to do a network co-occurrence graph. So I want to say that, you know, Georgia and the US were mentioned in the same rumor, you know, 20 times. So there's a thick edge between those nodes, and like Muslim and first were mentioned in the same rumor once, so there's a very thin edge between that node. So I'm looking for sort of like a topic model with weighted edges. Ayush says there's a concept called NLP.pipe for processing bulk docs. Oh, I'm not familiar with that. I want to look that up. All right, NLP.pipe spacey. All right, pipe abstract base classes. That looks like maybe not quite the same thing that you were talking about. Pipeline instance. Actually, you know what? NLP. Nope. Dot pipe. Is this an R syntax that doesn't work? Okay. NLP.pipe processes text as a stream and yields docs objects in order. All right, let's try it. Peep. All right. So I need to for, and I'm actually going to call this docs instead of docs. Doc in docs. This might have been that thing where I print it out and it crashes the notebook because it takes up too much space. I think that'll work though. And I think nested for loops in Python are actually kind of okay. Well, obviously you don't want to nest for loops in general just for time complexity reasons, but in R it is, the penalties are much, much more severe. In fact, for loops in general in R are just not ideal. So you want to vectorize everything, but my understanding is that vectorization in Python is not as central to good practices in the language. I'm putting my hair up while I wait for this to run. You know what? How about we just stop this? There we go. And let's get our thing back. All right. Keyboard interrupt. And did I also have an error? No, it was just a keyboard interrupt. So I want a data structure that has, and this is where it's gonna get a little bit dicey for me because my grasp of Python data structures is like, okay, it's fine, I guess. So I think that what I want the final output data structure to look like is I want it to be a data frame that has index of index of claim, and then I want it to have the and dot text. So I'm already looping through docs. Is there a simple way to get the index? I think there is. So if I initialize a counter out here, okay, and every time I go through another doc, at the end, I update it. Plus equals? Is that a Python thing? Or is that something you can do in Python? Count equals and ground. Okay. Although it should be incremented by 1, because if it's incremented by 0, it's always going to print the same thing. And then instead of printing, I want to append it to a data frame. Let's check out adding rows to a data frame in Python. Oh, it's .append. That's helpful. Append rows of other to the end of the frame, returning a new object. Columns not in this frame added as new columns. Here's my question about memory efficiency. Is this one of those things where, because Python works on copies, if I do appending in a loop, I'm gonna have a huge memory blow up and use up all my memory and it'll yell at me? I don't know the answer to that. Let's see. Aha! Iteratively appending rows to a data frame can be more computationally intensive than a single concat. A better solution is to append those rows to a list and then concatenate the list with the original data frame all at once. Knew it! I knew there was something. It was on the screen in front of me. I just wasn't reading it. Okay. How do I append to a list? Python. Append to a list. List.append. Okay. I think I want 2 lists and then I will add them as columns. So, list indexes equals no. Can I do that? Let's just try just that bit. Is that like a thing I can do? No. Maybe it's lowercase. No. Okay. Python, create empty list. Oh. Okay, just an empty pair of brackets. Well, that's easy. Is there a more efficient way to do this? Yeah, probably. List entities. And okay, so what I'm gonna do here is I'm gonna do list dot, nope, underscore indexes dot append, and then I'm going to append I, and then I'm gonna do list underscore entities, and I'm gonna append that thing that ent.text. Ent.text. Okay, and then, so what this should do is it should create two lists of the same length, one that has the index of where we got the named entity from, and the other that has the named entity. And the reason I'm doing it this way is I don't actually know how graph making in Python works, but at least in R, the sort of final output that you want is going to be easier from this type of data structure than a different type of data structure, at least in my experience. Let's try it. Let's see if it works, and then we can figure out how to get this back into a data frame, if a data frame is the right option. And it's gonna work for a while. Man, I hope this works. That's the other thing I don't think I've mentioned recently. Internet access. It is available. I think to everyone now. We're sort of like slowly rolling it out to catch any bugs and make sure we're not, creating headaches for folks. So if you have packages that need internet access, like I think Boca, a lot of Boca stuff needs internet access, or a lot of the leaflet, a lot of the sort of, especially map visualization packages need internet access. And now you can have it. So that's very exciting. Get rid of that. Goodbye. Oh, it's thanking. I'm so worried. I'm so worried that I'm going to create some horrible data structure abomination. Holy moly. So I'm definitely using a lot of resources right now. I haven't filled up the disk yet. That's what I'm worried about. Just like super, super, super memory inefficient. When I first started in R, it was the first like real programming language I'd actually done work in. Like I'd taken courses in Java and Visual Basic.net, believe it or not. And so I had like some background, but it was the first thing that I really like sat down and had to figure out how to do things in for my own work. And there was an incident. Hey, you can use multi-threaded batch approach. I can. I might want to try this. That might be a little bit faster. For doc and NLP pipe. Omar says, relax, that's the way we all code, with a Google tab open. Word. Oh no, I've lost the chat. There we go. I'm copying this code example that Ayush... Oh, it finished! Argument string has incorrect type. Expected string got float. Okay. Sorry for the formatting issue. Oh, no worries. No worries. Don't apologize. Whip. Interesting. And so the number of threads is based on the number of cores? Does that sound right? Well, I'm gonna take a look at a couple of these and see if if any of it actually works. 0, give me 2. Okay. Okay, that worked. List indexes and list entities. Hey, okay. It says not really about my question about cores. You can start with 2 to 3 threads. Okay, I think that would be probably much faster. I'm just gonna do that. That also looks more space efficient, but I am gonna have this also this index thread, so we don't have to we don't have to do that anymore because we're doing it there. I'm not sure why I'm getting this error because it seems like it worked. Yeah. All right, so I'm gonna really quickly go through and comment this thread since at least for the first time it worked, and then we can do something maybe a little bit more interesting than watching me flounder with data structures. I don't know, floundering can be helpful. Remove duplicate. What was this called? Claims. And this is the NER list we'll use. Initialize claim counter, and actually, you know what? I think claim counter is a much more transparent name than I. And lists for our entities. All right. And the other one was list underscore indexes. And I actually think I know the syntax off the top of my head. Famous last words. I think I can do data frame claim entity and ends. Just keep it consistent. No, it didn't work. Or maybe it's as data frame? Nope, that's also not a thing. Oh, from list. That was the one I wanted. Take multiple lists into a data frame. That's the exact thing I want to do. PD.dataframe. Okay, so it needs to be in curly brackets. Why is this the syntax? It's probably something to do with lists. It probably makes sense if you know C really well or something. Single quotes. Okay. Oh, but I also don't want just the first 5. Entities with entities claim index. And I'll do this so it actually looks good. Okay, moment of truth. Dot head. Nope, that's not gonna work. I hit caps lock. It's a dictionary. Oh, that does make sense. Thank you. You have clarified it for me. You've brought the light. Okay. I don't actually know that this should be a data frame. I'm just comfortable with data frames, man. Data frame with claim indexes and nope. Close enough. And we actually probably don't need the looking at the head command to stay in there. The thing that I want to do next is network visualization in Python. Network graphs in Python with Plotly. I am new to Plotly. I have not used it. Okay. Blah, 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 blah. Create edges. Oh my god. Are you kidding? You have to make the nodes and edges separately? I'm gonna look for an easier way to do this. Sorry, that's too much work. I am spoiled. I just want to give you a data frame. With open the file, create the nodes, create the edges. Create the graph, add attributes. Oh, that looks nice. Looks like there's a lot of functionality. I want this to be easier than that, though. Graph tool. Let's see about you. I am spoiled for graphing visualization tools. Yes, I want to create and manipulate graphs. Create an empty graph. Okay. Whether or not it's... Oh, it's directed by default. That's interesting. And I don't want a directed graph here, because all the directions are going to be bidirectional. Varun says, why are we using network graphs? Because I want to visualize what happens when I restart my notebook accidentally. Because I want to visualize what claims occur together most often, or sort of what entities and claims occur together most often. So do people have claims for the US more often, or I think this should still work. Or do people talk about different things together? Mad Dr. K, or maybe Madderk, suggests network X. Let's try that out. Python, blah, 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 function. Oh, that's so pretty. Okay, open source BSD. I want docs. Ooh. I don't want docs. There we go. All right. Zoom in. From Pandas data frame. Oh, I do like the sound of that. That's exactly what I want. Let's see if I can find a copy and pastable example. None there. Pandas. From pandas. Adjacency edge list. Adjacency edge list. From pandas data frame. So this may be Networks 2.0. All right. Unfortunately, in the meantime, I have somehow broken this code that was working. So, to plot network X from pandas data frame. I really wish they would let you post links in the Google chat, not the Google chat, the YouTube chat. That would be helpful. Okay, argument string has incorrect type, expected string, got float. Doc, self.make. Let me just try this bit and see if that's where the problem is coming up. No. Okay. doc in X. Let's just do like the first sys5. Print. Ah, crap. Okay, Python 3. Print with quotes. Python 2 is print without quotes. And let's just do end.text. Okay, that's working. For doc and docs. So the problem is, and I should have copied that instead of cutting that because now it's not in the place where it needs to be. One of the documents in here is having trouble. It might be this batch size parameter. That might have to be the same as the input. All right. It might have to be the same as the input. What's the word I'm looking for? The number of text to buffer. It could be that the batch size is larger than the number of texts that we have, potentially. What happens if I just get rid of it? Is that going to be an issue? Okay. Yeah, I think it might have been the batch size. I'm just going to not have it. Let's see what happens when I do this over the whole thing, though. Am I still going to get that error? Well, that's running. Let's find out about this library that sounds very nice and user-friendly. Previously, the function from Pandas data frame assumed that the data frame had edge-like list structure, but toPandas data frame generates an adjacency matrix. We now provide 4 functions: from Pandas edge list, to Pandas edge list, from Pandas adjacency, to Pandas adjacency. Okay, so toPandas data frame is the old, from Pandas data frame is the old data structure. What does an adjacency matrix look like? A, D, G, A. Adjacency matrix. No, that's not what we want. That's going to be way big for this data set. So we want an edge list. So the first thing we're going to need to do, did it work? Oh, it's still going. So the first thing that we're going to want to do is we're going to want to create an edge list. Which actually I think we should be doing at this step. So an edge list is going to look like, instead of Georgia first, US Muslim, it'll be Georgia first, Georgia US, Georgia Muslim, first US, first Muslim, US Muslim. So it has a pair of all of these things because all of these things should be connected to each other because they occur together. So I think what I actually want to do here and then I think I want to do, and I don't actually think I care about, so these would be the nodes, and I don't think I need them. Let me see what they want from Pandas edge list. Let me see what they expect the data structure to look like. Oh, yeah, it's because I can't spell. Convert matrix from pandas edge list. Return a graph from pandas data frame containing an edge list. The pandas data frame should contain at least 2 columns of node names and 0 or more columns of node attributes. I don't need any node attributes. Each row will be processed as one edge instance. Okay, so instead of scroll. Oh, no. It still has the same error. Okay, but it created a data frame, so. Not sure what's going on there. Return self.tokenizer text. Make dot self. Expected string got float. Is there a claim in our set of claims that is numeric? That's just like the number 4. Like somebody claimed the number 4 on the internet. I'm trying to remember what the command is to get the data structure of a to get all the types. Is it D type? I think it might be D type. Claims? No, it wouldn't be that. It would be claims. No, it would probably D type. Nah? Is that it? That was not it. Is D type a function? It's not. Oh, is D type a function? No. Get data type an array. Numpy array. Yeah, that's what I want. All right. It is D type. Oh, it's an attribute. Gosh darn it. I'm second guessing myself. Claims.dtype. D-type object. Okay, so you get an object data type if you have a mixed data type. Can I convert it all to strings? Convert numpy array to string. Strings. Convert array from float to strings. Okay. Blah, blah, blah. You seem a bit confused. So each item in the array must be the same size. String representation of float doesn't work this way. Yeah, but it's strings? It will always convert things to an array of strings of length 1. Okay. Yeah, I'm fine with that. So let's do claims dot as type string. And does this change it in place, or do I need to? No. Is arrays immutable? I can never remember what's immutable and what's not. Okay, strings are definitely immutable. For sure, I know that. Arrays maybe are immutable? Oh, is it maybe because I used unique? Does that convert stuff to unique? I don't know. Make sure it's all strings. Yeah. Yes, they are. Okay, so I need to make a copy and give it the same name. Oh, okay. This time I got an error much faster, so that's good. Argument string has incorrect type. Expected string got numpy string. Oh. The difference, special type of string you only use in arrays. No, no, I want to copy this and then I want to search for it. Oh, hey, I'm not the only person who's had this problem with Spacey. Argument type has incorrect string. Expecting Unicode got string. Expects Unicode strings, not byte strings. We enforce this in the interface because otherwise we'll get problems. You can paper over this issue, text.decode. But this will likely bring you more bugs in the future. Okay. The read. Expected Unicode, got string, codex.open. So those are file reading in and encoding issues, and that's not what I'm worried about. How to deal with PyCharm. Okay. Let's find out about these NumPy strings, these special strings that are just for NumPy. Extract from open source Python projects. Oh, no, these are just examples. Convert array to list of strings. Python. Maybe that'll work. Convert an array to string arrays in NumPy. Convert an array to an ordered list with the same items. It does not need to be a list. Oh, ordinary, not ordered. Oh, wow, this is tiny, teensy weensy. Python program, blah, 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 blah. Input, blah, blah. That's not helpful. So if I get rid of this, it takes a really long time to give me the same error. No, it gives me a different error. So the original error it was giving me was that it was a float and not a string. And the error it gave me when I converted to a string was that it was expecting a string, not a NumPy string. And I just interrupted that and stopped that running because it's going to take a minute. Mad Dr. K or Murdoch has a solution that is, oh, I see. So instead of converting the whole thing to a string, you go through, this is directly copied and pasted from the chat, thank you very much. You go through and you loop through the claims that we have, and then for each one, you make sure that it's a string. Okay. And this is going to make a copy. Although, no, it'll overwrite the original one. Or maybe pointers? I don't know. I don't know what garbage collection is like in Python. That is much lower level than I've ever had to mess with in this language, except for encodings. I am rock solid on character encodings in Python. All right. Meanwhile, let's get back to this edge list. So the thing that we're going to need to do is create an edge list of all, what would you call them? Topics that co-occur. So right now, it's still running. You just go through and you list all of the entities within each document. So what I want to do is I want to, for each entity, make sure it's paired with every other entity, but do so such that each pair only occurs once. Oh man, this would make a really good technical interview problem. There's got to be a more efficient way to do this than 2 loops, 3 loops. Yeah, I should stop putting loops inside other loops. The time complexity is getting bad. Let's put it that way. I want to say something. I definitely did this exact thing at some point in the past. And I'm trying to remember what the solution was that I used then. And I don't even remember what project it was on. Let's see if somebody else has worked on this. Create edge, create co-occurrence edge list. Turning keywords into a co-occurrence network. No, it's in R. No. Most of the network people, at least that I know, and there's going to be network effects because obviously I'm primarily an R person, use R rather than Python. Blah, blah, blah. Twitter data. Collect tweets. Common hashtags. Graph where hashtags would be nodes. Okay, so this is very similar to what I'm doing, except they're using hashtags and I'm using entities. And they are building a matrix. Oh, they're using Network X too. Oh. But they want to do it from a dictionary of dictionaries. So this person says, first of all, I would sort the entities first so you're not continually running sort inside the loop. Then I would use iter_totals.combinations to get the combinations. The straightforward translation of what you need with these changes is... okay, so they've created a dictionary, which we don't necessarily need to do. So the first and the second in combinations sorted common entities. So this common entities list would be like the one that we are getting. Is it done? Oh, it's done. Okay. Oh, wait, no. I rescind my claps. My claps are removed. Okay, I think I figured out what the problem was and why we have a float. Oh, okay, and I also know why that happened. So that happened because I was futzing around while we were running it. And the reason that we have a float is because one of our entities is 911, and 9 divided by 11 is a float. No, wouldn't that be an integer? Again, Python data types, my Achilles heel. I've got a lot of Achilles heels. I'm like a spider in terms of how many heels I have. But I guess also spiders are good at things, so that works out. Yeah. So it would be if these weren't just the one thing that I had done because I messed it up. So we're going to run this again very slowly. So this common entities would be the 4 entities that we had here that was like Georgia, US, First, and Muslim. And then you sort them. And then you take all the combinations. Okay. And then and you sort of put them next to each other. So it's like A in column 1, A in column B, B in column 1, B in column 2. Oh, wow. C in column 1, C in column 2, D in column 1, D in column 2, and so on. And then if for one of the rows, the first and the second are not the same, then the combination of whatever the first and the second is gets a weight of +1. Okay. In this dictionary. Okay, so I was originally saying we didn't want any, what's the word I'm looking for? We didn't actually want any attributes for our graph. We just wanted the edges, the nodes between which there were an edge, but I think that it does make sense to have an edge of co-occurrence. Okay, it may be more efficient. Are you still going? Yeah. It may be more efficient. less indexing and fewer objects created to build something else first and then generate your final answer in the second loop. The second loop won't run for as many cycles as the first because all the counts have already been calculated. Also, since the second loop isn't running for as many cycles, it may be deferring the if statement to the second loop could save more time. As usual, run time it on multiple variations if you care, blah, blah, blah. And then this is... Okay, so here is creating all the combinations and then taking that dictionary and going through and counting how often each of them occurs. Okay, let's try this. Let's see if it works once this is done running. And I'm going to leave myself a little to do because I'm getting close to running out of time. I might come back to this next week. This is an interesting problem, and also I do want to know. I'm just curious. Figure out if this works to create a co-occurrence count for each pair of named entities. So we'll go back and do that. And I'm also giving myself note code from where I found it, so I can go back and find more information if I need it, which I almost certainly will. And that's going to be wrapped real ugly. Oh well. Oh, this is Python 2, isn't it? Well, that may or may not work. We'll find out. Actually, let's find out right now. Default dict is not defined. I think that might have... Okay, so that's definitely just a... A to B, wait, 2. A to C, wait, 2. Oh, because there's 2 A's. Okay, so what this is saying is that A and B occur together twice. So that's because here's an A and here's an A and here's a B. So A and B occur together once, and then A and B occur together a second time. And the reason that the A's are all multiples of 2 is because there's 2 A's. Okay. Will this work for let's move these up to the top. Actually, no, we're not sure we're going to use this yet. So let's leave them down here for now. So let's try print. We might not even need to have done this whole loop. Things that are created in a loop in Python only have scope within the loop, right? That sounds right to me. That might not be right, but it sounds right to me. So, actually, let's just do this. Oh. So now we're just going to do a little bit of testing to see if this works. Oh my gosh. So doc in NLP types. And then docs, take the first one, dot ents, and then let's see. First of all, let's see if that works. It did not. Okay. Oh, okay. No, that's not the problem. The problem is me trying to do this. Generator object is not. So let's actually just do let's do this the dumb way first. So we're just gonna do that. All right, so then we've got our list. I think that this may be expecting the wrong type of, I feel like there shouldn't be a space there. This may be expecting the wrong type of data structure, but it might work. What do you know? It worked. Okay. 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 And now let's try, instead of all this nonsense, get rid of that. Actually, you know what? Instead of just getting rid of this, I'm going to comment it out. Oh, what? As soon as there we go. On the 50th try, as I try to remember the keyboard shortcut for it. So what I'm gonna do is failed to copy and paste. Oh my gosh. It is the end of the work week and I am definitely feeling it. So what we're gonna do is we're gonna do this co-occurrence function, and I think there's a way to Python add dictionary to another dictionary. Append a dictionary. It is update. And then we are gonna start with an empty dictionary. Empty dictionary. In curly brackets. All right. Let's call this co-occur edges. Okay. And instead of doing the whole thing, I'm just gonna do like the first three, just so it's a little bit quicker to run and we can take a look and see how it looks. Okay, that was pretty fast. That makes sense because dictionaries are hashed in Python. I do know that. And let's see what our co-occur edges looks like. No. Oh, that's right. So the reason it didn't update is because I was having it do docs every time. So I ran it again. Let's see. It should now have more items in it, and they all have one. They only have a weight of 1 because they only occurred together once. All right. Okay, we're making strides, and so that worked. So I'm gonna get rid of you. I'm going to, I'm actually going to leave in this little example because I think it's helpful. I'm going to get rid of this. All that work. That's okay. Oh, and instead of just doing the first 4, I'm going to do all of them. And that's going to take a minute. And then... Oh, they actually talked about the name of the function that they were using. I'll have to go back a little bit. I Googled a lot of things. And the function that they were using was networkx from dict of dicts. And is it going? Yeah, it's going. And have I actually imported networkx? I have not. And I think it looks like the standard is actually to import it as NX. Let's check out the notes. Oh, nope. I don't need to know how to install it. It's already installed. Thank gosh. Yeah, as NX. Yeah, I know. You don't have to do like the thing that everyone else does. It just makes it harder. Easier to debug. I think. It's still thinking. Okay. So from dict, let's check out an example of how this is going to look. And that's what I want, the Python function. Okay, return a graph from a dictionary of dictionaries. A dictionary of dictionaries adjacency representation. A check. Create using you specified graph result, otherwise new graph is created. That's fine by me. Multi-graph input, will true, the values of the interject are assumed to be the containers of the edge data for multiple edges, otherwise this routine assumes the edge data are singletons, which is what we want. All right. So we can just do, that's it. It's just nx from dict of dict. And it looks like the standard is to use a capital G to represent whatever your graph is. Create a graph from co-occurrence data. You done? No. Okay. And that should work. It should work. We can also get rid of a lot of the stuff that I was just futzing around with. You still going? Oh, name network. Oh, yeah, it wouldn't be, huh? Okay, how do I see it? How do I see it? Drawing, that's the one. Oh, it's a matplotlib. Well, hopefully it's a nice wrapper. I have mixed feelings about matplotlib. Draw the graph G with matplotlib. Do I need to import it separately? I guess we'll find out. Draw G. Name draw is not defined. Probably because it's nx.draw, huh? Type error. Draw networks. Default to spring layout. Function object is not iterable. Noted. Okay, that's noted. I didn't pass anything to dicts of dicts. You are absolutely correct. I did not. Excellent catch. And then it is called co-occur edges. That would also explain why it took literally no time to create. Oh, and it was a function. Okay, yeah, I get it. I get it. We just called G the function from dict of dicts. All right, so now that we're pretty sure we're using this, let's move all of our imports up to the top. Let's be PEP 8 compliant. I love PEPs, guys. I do. It's nice to have standardized standards. I was trying to think of a word other than standards, and there just weren't any coming to me. I can get rid of that. I'm gonna add a little markdown cell. This function takes a string or array of strings. And returns a dictionary of dictionaries with a count of how often each unit co-occurs. Actually, I think it will probably take more than that on account of type mutability. Function from Stack Overflow user Patrick Maupin. Moppin? I don't know. And quickly insert a link to that. Well, we are still waiting for this code to run. Graphs take a bit, generally. Oh, well, that's not so good. Let's go back to my notebook, which is being saved as we went along. And it's probably just as well that we restart and run from the top. What did we lose? Okay, we didn't lose much. We just lost that we had all of our imports at the top. And also our nice little paragraph, but we can write our nice little paragraph again as we run the whole notebook top to bottom. So that's gonna take a second. Function to return a count of co-occurrences as, oh, that's not even close, huh? As a dictionary of dictionaries by Stack Overflow user. Nope. Get Patrick's name again, because there's no way I'm going to spell that correctly on my own. Get rid of this, that's not so helpful. That is one thing I don't like as much when you're running the whole notebook, is you don't see that they're done with a cell until they're done with all the cells. So sort of like all the cells are loading until they're all done. Yeah, just, you know, it's fine. Although you can check what's going on down here. So we are, no, you don't. It's all plotted all at once. Whoop. Oh, yep, that would do it. Okay, so whether or not this works, I think I am going to call it a day because it's been a little bit over an hour and it is Friday night. Now I'm gonna head out and have dinner with a friend, and I will see you guys next week. And I'll be back from the joint statistics meeting, so I will have all the cool gossip from statistics. I don't know, there might not be that much cool gossip, but there might be, who knows. And I will see you guys when that rolls around. And yeah, we'll probably keep working on this, unless this just works really well, in which case I'll just make it public and you guys can take a look at it. Thanks for joining me. I hope you guys had fun. I really enjoyed today. This was a lot of fun. And I'm excited to see the final graph and the sort of the output. Yeah, absolutely. Actually, let me just make this public right now. Whip. And the code is Rebecca Turner is my super secret name on Kaggle when I'm not using an admin account, and then it's just named entity recognition. I'll see you guys next week. Bye. Thanks.